Hello guys, my name is Ritik and you are watching DSA series episode 1. In this series, we are going to cover many DSA questions and I'll be providing solutions to them questions. And I'm a software engineer working in Bangalore. Okay, so in this series, we are going to learn from how to find a solution of any question, any DSA questions from basics to and how to think of any solution in a brute force manner and then go to the optimized version. Okay, so in this question, this is an array question, and we are going to start with this question. Uh, to This is the first question of our series, so please watch till the end of this video to understand completely. Yeah. So this is the question of lead code 153. It is find minimum in rotated sorted array. So in this question, we have given already a rotated sorted array. So the example we can see 3 4 5 1 2. Okay, so all the elements are present like 1 2 3 4 5, all are there, but they are sorted also, but they are in rotated manner. So two things we can understand from this question, like we have given rotated sorted array, so we know like if it is rotated, so it can be sorted at most two times. Okay, the first is 3 4 5, other is 1 2, both are sorted. Okay, so which means it includes two parts of array, so both will be sorted. In the second example, we can see that like 4 5 6 7 is also sorted, and 0 1 2 is also sorted. So they might be separated in the array itself, but they are sorted. Okay, so we can use that sorted thing to find a solution for this question. Okay, what we have asked in this question is find minimum in this rotated sorted array. Okay, so as we know, the first thing that comes in our mind to find the solution of this is the brute force solution. Okay, we will think of this question like we'll first sort this array. Okay, then we'll get 1 2 3 4 5. Okay, and we will take first of the element of this array, that is 1. So we will get the correct answer, which is minimum in this rotated sorted array. But as we know, we will sort this array and like using any algorithm or directly using sort of C++ programming, which will take we go for n log n time. Okay, so and we will take directly we'll get a minimum element after just sorting. Okay, so this time or complexity of this approach is we go of n log n, which is not optimized. So we will think optimized version of this question. Okay, then we will think like we can also traverse the whole array. Okay, and we will make a variable like something mini or something, and we will traverse the whole array if we find some minimum element like like in comparison of that mini variable, we will directly replace the mini variable with the what minimum element will get in while traversing the array. Okay, so this will take the time complexity of O of n. Okay, which is better than that the previous approach. Okay, but it is not optimized because it is taking O of n time. Okay, because we have to traverse the whole array. Okay, and we are not using that thing that already given that it is a sorted array. Okay, now it comes the optimal solution. Okay, as we have given this is our array is already sorted. Okay, and we have not used this thing, like if the array is already sorted, we have to use this thing, correct now? So for this thing, we will what will first will do, think of any solution which uses sorted array. Okay, like in which approach we use, we have sorted array, then we can use the approach. Okay, so that approach is binary search. Okay, like if we have given any sorted array, the first thing should come in our mind for optimal solution is binary search. Okay, so the best optimal solution will be using binary search. Okay, so for binary search, we are going to code the solution. Okay, which will take big of log n time. Okay, because the time complexity of binary search is big of log n. Okay, so we will going to write this code for this problem. Okay, using binary search. So this will be the most optimal solution for this problem. Okay, so directly we type to the solution, then we will understand while coding this question, we will understand how to find a best like how to write a solution using binary search. Okay, so first we will take a variable. Okay, n is nums of size. Okay, I'm going to code for this question in C++. Okay, so now we have defined this n equals to nums dot size. Okay, now what we will do for the binary search, we need two pointers, left and right. Okay, left will be pointing to the start of the array, and right will be pointing to the end of the array. Okay, so we will take two variable. First one will be at index 0 and other will be at n minus 1 at the last index. Okay, so now for binary search we will use a while loop. Okay, while l is less than equals to r. Okay, because for binary search approach we traverse until both left and right index will be crossing to each other. Okay, until then we will using this while loop. Okay, so here the main thing is mid element. Okay, mid element is found by left plus r by 2. Okay, in this way we will get a mid element of this. Suppose that this example of first we have given 3 4 5 1 2. Okay, left will be pointing at index 0. Okay, and right will be pointing at 4. 0 1 2 3 4. Okay, so for this question, okay, if we will find the mid of this element at this time, like left is less than equals to r, because 0 is of course less than equals to 4. Okay, so now we'll use int mid equals to l plus r by 2. Okay, we will get 0 plus 4 by 2, which is 2. Okay, now we will check at index 2, which is of course v of 2 is 5. Okay, so we know this 5 is of course greater than v of l, so we will going to use this thing. Okay, if v of mid is greater than equals to v of l. Okay, so now think of this, like how to find the best solution for this. Like think of this question, like approach, how to use this approach and what is this approach. So v of mid is greater than equals to v of l, which means 5 is greater than 3. Correct. So as we know, if it is greater than 5 is greater than 3, that means we have given rotated sorted array. Okay, so either it is possible that our array is already sorted. Okay, so in this case there might be condition that v of l will be the many element, so we will update many. Okay, and v of take v of l. Okay, we have to define this mini also at above. We'll define here. So we will take as any element, but now any number or any element, because it will be modified later. So we have to take minimum element. So we'll be taking v of 0. V of okay, we are using v, so we have to define here v, and also here. So we will taking v of 0 here. Okay. So in this question, as I told you, it may be possible that 3 is the minimum element. Okay, because v of mid is 5. Okay, and v of l is 3. Okay, it might be possible if v of mid is greater than v of l, it may be possible that array is already sorted. Okay, in that case we have to override the mini, so we'll using mini equals to min of mini comma v of l. Okay, because v of l can be smaller. Okay, but in if it is not smaller, we know the array is rotated. Okay, so that means like after 5. Okay, before 3 to in between of 3 to 5, there is no possibility of having any minimum element. Okay, we have already considered 3. Okay, that is mini equals to mini of v of l. Okay, so now there is no possibility of 4 or 5 as a minimum. Okay, so we have to move to the right of v of mid. So we will move l is left pointer to the mid of move to the next of mid. Okay, that is l equals to mid plus 1. So now we have l at pointing at index 3. Okay, which is v of 3, which means v of 3 is 1. Okay, so now our while loop will move in between of v of 3 to v of 4, because we are not changing r, because right index will not change here. Okay, and else condition can be here. Okay, In else condition, like maybe v of mid is less than v of l. Okay, in that case, what can be possible? Suppose that 3 4 5 1 2. Okay, think of a like 5 in place of 5 there can be 0. Okay, so if 3 4 0 1 2 you have given, okay, which is also rotated sorted array. So 3 4 0 1 2. Okay, so like I will explain you here. Think 1 second so that you can explain understand better. So suppose that you have given the array 3 comma 4 comma 0 comma 1 comma 2, which is also a rotated sorted array. Okay, but in this case v of mid is like l is at index 0 and r at index 4. Okay, so we will divide 0 plus 4 by 2, which is 2, which means v of 2, which is 0. Okay, so in this case v of mid is not greater than equals to v of l, because v of 0 is like v of mid is actually it is less than of v of l. Okay, so in this case you can understand one thing: either v of mid is the smallest element. Okay, so we'll update it according to according to this approach also, like mini can be the min of mini comma v of mid. Okay, and other thing is possible, like if in that case suppose that in place of 4 there is possibility of something like maybe 0 is in place of 0 there may be 1, and in place of 4 there may be 0. Okay, so in this case your uh, suppose that there can be something like this example: 3 comma 0 comma 1 comma 2 comma something like this. Okay, second something like okay, so suppose that 4 is here, okay, and 3 is here. So in this case at first you'll be getting v of mid is 1. Okay, which can be minimal, but we know v of 1 is v of mid is of course less than v of l, so we can't move right to the v of mid because the array is already sorted. Okay, only one time, not more than one time. Okay, so there is possibility that your sorting will be before this one, like sorted a minimum element before this one, or maybe one. Okay, so that's why we'll move this this right pointer to the mid of -1. Okay, so now right will be pointing to the zeroth, this zeroth number, that is first index. Okay, and we have already considered this v of mid, so that's why we have already checked that condition. Now will right will be pointing to the v of index 1. Okay, so in this case again we'll handle all these things in this approach. Okay, in the end after this we'll be returning this mini element that we have found. Okay, now we will run this approach and we'll check if it is any error is there or something. Okay, so all the test cases are passed. Okay, now we will try to try now we will try to submit it. Okay, yeah, so that is correct, and we have got 100% accuracy. Okay, because binary search is the most optimal way to find answer for any sorted array. Okay, so in the future if you get any question, okay, in which you get any sorted array, then just think of binary search approach first. Okay, then move to the solution. Okay, so this is it for this video, and we'll meet to you in the next video. Okay, if you like the video just like and subscribe, and okay, bye bye.